This is concave up and this is concave down, and for any function y(f(x), we can tell whether at any point the function is concave up or concave down by looking at the sign of the second derivative at that point. So we know that first derivative tells about the gradient of tangent at any point, and the gradient of tangent becomes 0 at the stationary point where the function is a maxima or minima. And as I talked about in the second video, in the last video, sorry, that the looking at the sign of the second derivative, we can tell whether the maxima or minima is a whether the stationary point is a maxima or minima. So if the second derivative, that is f double prime x, is positive greater than 0, then that point is the stationary point where the first derivative is 0 is a minima, and if it is less than 0, then that's a maxima. But for any point where the second derivative is, where the first derivative is not 0 but the second derivative, looking at the sign of the second derivative, we can tell whether the function is a concave up or concave down. So if the second derivative is greater than 0, the function is concave up, cu, and if the second derivative is less than 0 at any point, then the function is concave down. And this reason is when it's concave up, the second derivative actually talks about the rate of change of gradient of tangent, because this is first derivative, which is the gradient of tangent, and the second derivative will say about the rate of change of that gradient of tangent. So when the second derivative, when that rate of change is positive, that is this one, then this is a concave up. So that's this case. And when the rate of change is negative, so this is decreasing, the rate of change is decreasing. So when the rate of change is decreasing, that is this one, the function is a concave down. So it's negative, that means it's less than 0, rate of change is less than 0, the function is concave down. And there is a point when the second derivative is 0. That point is where this is called a point of inflection, and that is the point where the concavity changes. So let's say we have like that function like that. So this part is concave up, this part is concave down, and this is somewhere the second derivative will be 0. This is where the second derivative will be 0, and this point is called point of inflection. So the concavity changes from here to here. The gradient is not 0 here, first derivative is not 0, but second derivative is 0, and we can check the concavity by looking at the second derivative, sign of second derivative just towards left and towards right from that point of inflection where the second derivative is 0. Similarly, it can be this one, another. So this part is concave down and this part is concave up, and this will be again a point of inflection like that. So second derivative will be 0 here. So it's just the basic I will try to do some examples soon.